We're gonna carry on this theme that Dr. Felix did such a great job of introducing, and my role, I'm gonna focus more from the feedlot, and even not so much the feedlot, but the value that these carcasses have from what we're trying to produce. We're trying to produce a real high quality beef product, right? And as Dr. Felix said, in 2017, those of you that have been around the country, you know there's certain pockets in the United States where historically we fed a lot of calf-fed Holstein steers. If you've ever been to Southern California, the Imperial Valley, there's 10 family feed yards down there that used to feed a tremendous amount of calf-fed Holstein steers, and there were packers they built their own packing plant in Brawley, California to do that. Okay, but as that expanded, what our original goal was, when we think about the meat quality, the first charge we had at Texas Tech, and we did a lot of work at Texas Tech. I got a couple colleagues there that are basic meat scientists, Dr. Dale Warner and Dr. Blake Forker. And so our first charge was, let's try to make these cross cattle better than a straight dairy influenced steer, right? That's all we were dealing with early on were steers. And so it's interesting that now we've evolved, and I'm going to end my talk today, we've now evolved to, we're trying to make these better than beef. And I think we can get there. I'm going to show some data of 3/4 of the carcass is as good as beef is right now. We just got one area of the carcass we need to work on, okay? So I'm going to focus a little bit more on the meat science and muscle biology part, kind of what the packer wants, but ultimately it's what the feedlot wants from your dairies and your calf ranches as well. So I'm going to go through about 3 different parts to that. As Dr. Felix already said, what has really brought us here? We can talk about the packers saying, hey, we don't want straight calf-fed Holstein steers anymore, but there's still regional packers that love those, okay? So that wasn't really the main impetus. I got a former grad student, and I'm going to share much of his data this afternoon. Dr. Luke Furness got a PhD with me, and he put this slide together. And I think all of you in the room can relate to this. It's these 2 on the right that really drove the beef on dairy phenomenon, right? The ability to buy sexed or sorted semen so you could produce more heifers from a mating. That was one thing. But then being able to genomically test those heifers and mate the very best young females to the very best sires to get more high-end heifers opened up a lot of uteruses in the dairy industry, right? And that allowed us to start thinking about using other semen, beef semen, to produce a higher yielding animal from a beef perspective. I'm glad Tara showed all the semen sales, and I figured, knowing the title of her talk, she was going to do it, so I'm not showing any semen sales. But that same grad student I talked about, Dr. Luke Furness, when he first started with me before COVID, he was interested in beef on dairy, and that's why he came to Texas Tech. I just want to take a little time. What this graph is anything you see white. So if you go way over here to March of 2019, so basically 6 years ago, there's a very common, there's a stockyard in Hanford, California called the Overland Stockyards, and they have monthly video auctions, and they really set the basis for the rest of the country for dairy-influenced feeder cattle. They have for many, many years. Many of you maybe have heard of Overland Stockyards. But what Luke started doing is he started measuring the breed compositions of the cattle that would sell every month. And he did this out till when he got his PhD in 2023. And all I want you to look at is the transition over time. In 2019, over 95% of the marketings, month in and month out, or week in and week out, were still calf-fed Holstein bull calves or steers. Okay? Look at where we've come to now in 23, and we've kind of plateaued out, where 75% is something else. Okay, and the big one would be beef on Holstein, any beef breed, and then the gray bars here would be either a Hojo or a Jersey and beef on that, okay? I would argue we're not going to get any higher than probably 75%, because the dairy industry still needs heifers, right? So that you're still going to need to maintain a certain fraction of those cows. But what a transition in this time frame, 4 years. In 4 years, one of the most major stockyards that sets the basis for dairy-influenced feeder cattle went from 95% calf-fed Holstein steers to something else, right? And now only 25% being marketed as calf-fed Holstein steers. So some advantages, and the whole theme this afternoon, I'm going to make a lot of comparisons to an all-beef animal and then an all-dairy animal, namely a calf-fed Holstein steer. But when we start showing the beef on dairy, that's going to be in the middle, okay? And we're going to go through a lot of different kind of data. So what's some positives and negatives of feeding an all-beef versus an all-dairy animal? First and foremost, generally speaking, an all-beef animal is going to have the most superior, the best feed efficiency, okay, especially compared to a straight Holstein. And part of that has to do with GI tract mass, and we'll talk more about that as we go through. They also are going to have the best muscle to bone ratio. Now, this doesn't say anything about back fat or fat thickness. This is just the relationship of muscle, red meat, relative to their bone mass. We all know dairy animals, especially Holsteins, have a higher bone mass, correct, compared to beef breeds. So they excel in muscle to bone ratio. Where they come up short today, we overfeed these cattle, right? We put excessive amounts of back fat on beef cattle, and they're prone to deposit as much. We keep feeding them, they'll keep adding 1/10 of an inch every week or so at the end of the feeding period. On the flip side, the dairy-influenced animals, one of the negatives is, I grew up in a feedlot in South Dakota, and at any given time, 1/3 of the feedlot back in the 70s and 80s were Holstein steers, okay? They could find a way to get any gate open on the feedlot, right? You'd wake up and here'd be a pen of Holstein steers walking down the driveway. The beef steers never did that, but their behavior is unique. What are some positives? The big one is we have a consistent supply. Historically, on the beef side, we're calving at best twice a year, spring or fall. We're having calves every day on a dairy, right? So we have a consistent supply. And I'm gonna tell you what makes good butterfat production on the dairy side makes good marbling development on the muscle side. There's a great relationship between selecting for milk production and selecting for high quality meat. And historically, they always have been noted as very tender and having a high degree of marbling. So I want to just set up, I'm going to share some data here with you from Luke's dissertation. And one of our interests was we wanted to specifically understand how the dairy management system could impact beef production in general. And to do that, what we did, the first 5 columns here, the first 5 treatments, all these calves that were generated from these matings were half sibs. We used the same Angus bull, a bull called Momentum. My colleague, Dr. Ryan Rathman, let us breed the TTU teaching herd to that bull. So we got some offsprings, about 40 calves out of our commercial beef herd at Texas Tech. We implemented, we collaborated with Simplot's HerdFlex group, and we used in vitro fertilization to use that same semen to generate all beef embryos that were then placed either in Holstein cows or Jersey cows. But these, again, were all half siblings. And then finally, we used the same bull, Momentum, and we bred a bunch of Holstein or Jersey cows. So the offspring, and we had both steers and heifers, the offsprings were all half sibs. we published all this work. We were interested in knowing how they grew in the hutch, okay? And I'm not going to talk about any of the early calf work today, but that's all published in Translational Animal Science. All the other feedlot and meat quality papers are all published in Journal of Animal Science. So once the animals got to the feedlot, we wanted to bring in a straight-bred Holstein. Obviously, they're not half sibs, right? So we used an Angus bull on 5 of them. We brought in some calf-fed Holstein steers to the feedlot. And so our calf ranch part lasted 200 days. And then we made a decision to get all the animals to 700 pounds. And we started the feedlot portion. So the key thing is I show you all the data. We started the feedlot portion at 700 pounds, including the calf-fed Holstein, the straight Holsteins, and we fed everything a set number of days of 200 days. So we tried to eliminate some of the variation. So here's just some pictures. This is the age at trial initiation of the feedlot. Now, 5 of the treatments we controlled from conception, okay? We made the genetic decisions on the dairy. It was a father-son dairy. The son had the Holstein herd. The father had the Jersey herd in eastern New Mexico. But this is actually the age of the calf once they got to the feedlot, when we started the trial at 700 pounds. So we had a growing period for some of these animals. So our conventional beef animals had a very heavy weaning weight at 200 days of age. It only took them 231 days to weigh 700 pounds. So these would be calves raised on our Texas Tech cow herd. If we go over here to the F1, the Angus semen in the Holstein cows, they were 279 days of age when they weighed 700 pounds and we started the feedlot portion. The 2 embryo groups were a little bit older. The all beef embryos in the Holstein cows were 301 days, so they had a little slower growth in the hutch, in the calf hutch, being an all beef animal. And the all beef embryos put in Jersey cows were 283 days. We have a pretty good idea. The Holsteins were roughly about 260 to 270 days of age when they weighed 700 pounds. The outlier here is the Angus Jersey, right? And we all kind of know this. Again, same sire. They were 11 months old, basically. It took them 11 months to get to 700 pounds. And then we fed all of these a flat 200 days and harvested them. So we know we have differences in weight, but we wanted to be consistent on days on feed. This is what they looked like the day before we shipped them. So this is our final shrunk body weight. And just a representation, these were averages of about 20 head per group. One of the heaviest ones was, again, our all beef control. They weighed 1470, a shrunk body weight, so their full weight was well over 1,500 pounds. Again, these are all half sibs except the Holstein. The all beef embryo weighed 1,400. The all beef embryo down here, very similar, 1,379. The lightest one, of course, the Angus Jersey at 1,281. I want to point out, I'm going to make 2 comparisons. I want to compare the F1 here, the Angus semen in the Holstein cow, to the all beef IVF embryo in the Holstein cow. Keep these weights and remember these weights. That F1 was 40 pounds heavier. Okay, everything else was constant, 200 days on feed. The F1 weighed 40 pounds more live weight when we shipped them. Remember 40 pounds, and we're going to come back to that. So again, here's just the numbers in tabular form. I'm going to come down and talk a little bit. I'm not going to spend a lot of time on the feedlot side, but I'll tell you what, the F1s, our best feed efficiency in the feedlot was the actual Angus semen in Holstein cows, the F1s. You can see we had very respectable 5.85. We had very desirable intakes. Gain was good. Remember, they went out weighing 1440. Remember that? They were 1480, and the other ones were 1440. These weights are a little off because actually this is not final shrunk. This would be empty. We shrunk some more to get to empty body weight. So here's what one of the take-home messages I want for you. If you've not been around feedlots and packing industry, I just got done telling you that these animals were 40 pounds heavier on a live weight basis, right? Look at their hot carcass weight, side by side. 883, 881. We lost that 40 pounds of live weight to what we call dressing percent or yield. And so the all beef animals will always have superior dressing percent or yield of hot carcass weight to live weight. Where did that 40 pounds go? Most likely GI tract mass, right? All of you in the dairy industry, you select for high intake. With that comes large GI tract masses. Half of the genetics get passed on to these steers, and they're gonna, one of the downsides that we still deal with is that they're gonna have a little bit lower dressing percent or the yield of hot carcass weight to that shrunk body weight that I showed on the previous slide because of non-carcass components that get dropped into an offal barrel, and one of the main ones would be the GI tract mass, okay? The other two things I want to point out on this slide, we're gonna spend a lot of time in the last half of my talk. There was absolutely no difference in ribeye area. Even the straight calf-fed Holsteins had the same ribeye size. Remember that. This is a huge part of how we're going to make beef on dairy better. The genetic companies have done a phenomenal job of using ultrasound to develop EPDs on the beef side to give us the size ribeye we want. We tell them we want a 14.5 square inch ribeye, they will give it to us. Okay, that's the promising thing, is they can start delivering other things to us. The other thing I want to point out, one of the big advantages of dairy or beef on dairy comes to fat thickness. Remember what I said on one of my intro slides. These cattle are leaner. They have less back fat, but yet they maintain marbling. Okay? Remember, this group had the best feed to gain ratio, the best feed efficiency. One of the big drivers of that is they had less back fat. Their composition of growth at the end of the feeding period was less adipose tissue and more muscle, and that led to better feed conversions in that situation. The final thing is, the bull we selected, Momentum, was in the top 1% for marbling, intramuscular fat in the Angus breed. We know Angus is noted for marbling, right? 500, which our Holsteins were, is small. 500 is small zero. So the Holsteins came in almost at average choice, which would be modest. That's really good. That's typical for a good calf-fed Holstein. These high 7s and 8s, 800 is prime, low prime. This was our average, okay? Even in the Angus Holsteins, 55% of those carcasses graded prime, okay? So my point is we have the genetics out there on the beef side to produce as much marbling as we want in these beef on dairy crosses, but also get good feed efficiency. Remember, I showed you, these were the most efficient ones, and they were averaged right below average prime. There's a huge economic advantage right now for the last 5 years. The spread between prime carcasses and choice have been as high on average as $40 a hundredweight of carcass. So if you have a 1,000-pound carcass, that's an extra $400 for a prime carcass over a choice carcass. So again, that's another value to the producing these beef on dairy. We can get very, very high quality carcasses. So the last part of this discussion, remember that ribeye was identical across the board. Currently, ribeye is our main determinant of red meat yield or yield grade, USDA yield grade, which means the cutability or the red meat yield of a carcass. And so we've done a great job of standardizing ribeyes. They were all in the 14s. Even our straight calf-fed Holsteins average 14.1. And why this becomes important, we're going to talk about meat quality for the rest of the talk. We do a lot of fiber typing in our lab. And this was an original data set that one of Dr. Warner's grad students did for her master's work when we first started this beef on dairy meat quality work in 2019. And we've yet to publish this, and I've gotten after Dr. Warner, but we see this consistently. Beef cattle are just like us as humans. Bovine, all cattle, have 3 predominant fiber types that make up muscle. And what defines that is myosin is the most abundant protein in muscle. It's responsible for muscle contraction. It's an enzyme. So the red ones here are the oxidative fibers. These are called myosin heavy chain type 1. The orange or yellow ones are myosin heavy chain 2As. We call those intermediates. And the ones we don't stain on our histology work are type 2X. And you'll notice they're the biggest, right? And those are glycolytic fibers. We as humans have the exact same myosin heavy chain isoforms as cattle do. Okay? So a sprinter wants a bunch of these. A long distance marathon runner wants a bunch of oxidative fibers. Dairy influenced animals, all dairy animals, these are calf-fed Holsteins, they're going to have a lot higher percentage of oxidative fibers. And that can have some benefits, it also can have some negative consequences. What I'm most excited about with beef on dairy is it's like we do a transition from oxidative to glycolytic, but they get stuck in the intermediates. And that's a good thing from a meat quality perspective. This SSF stands for slice shear force. So they're actually more tender than native beef because they have more of these intermediate fibers. And we only get marbling with the oxidative fibers. Half of these intermediates are oxidative, the other half are glycolytic in a metabolism standpoint. So I think one of the benefits of beef on dairy is, in fact, we have a very acceptable meat quality issue because I think we need to learn more about how the genetics can potentially impact this fiber type and keep more of these in the middle because it's more forgiving from a cooking standpoint and from an overall meat quality perspective. Another big thing is just red meat yield. One complaint we always have with all dairy beef or calf-fed Holsteins is that the strip loin, so from the 12th rib back to the sirloin, as we get closer to the sirloin, we get a very narrow steak. We call that a vein steak in a calf-fed Holstein. When we put beef on the Holsteins, it looks much more like an all-beef steak. So it's much more acceptable from a steak dimensionality standpoint. The retailers, this is much more appealing in the eyes of major retailers. And the other major issue with dairy beef is going back to the retailers. When we put these steaks in a tray and we overwrap film on it, the retailers want to sell that in a very timely fashion, right? If it sits in the retail case too long, if it has a lot of oxidative fibers, those red fibers that I showed you, they have a higher myoglobin content. That myoglobin becomes discolored and you'll get these brown spotches on the ribeye steaks. The average consumer, they think it's contaminated, right? But in fact, what happens is when we put beef on dairy in the retail case next to all native beef, it discolors at the same rate, much slower than all dairy beef. Many of you may know Dr. Dan Schaefer, who was at the University of Wisconsin for years, a pioneer in dairy beef production. Remember, he did all the work where he fed high levels of vitamin E. That was done in Holstein steers to extend the shelf life for retailers, because if they can't sell this as a ribeye or a strip, they have to grind it to ground beef, and obviously the value of ground beef's a lot less than the value of selling a ribeye steak. So we believe this is a huge positive, and we think the fiber type differences that I showed you is kind of contributing to the slower discoloration of beef on dairy. Again, just some more fiber work that we've done. In the end, at the end of some of Luke's work, again, this just kind of shows that the beef on dairy are intermediate. They have a lot more of these type 2A fibers, and in the end, that's where some of the marbling's coming from, and it leads to a much more tender product. I talked about the vein steak. So again, as we go from the 12th rib, where we rib these carcasses, to the sirloin, the end of where we get the New York strip steaks from, the longissimus laborum muscle, the problem with calf-fed Holsteins is that if you look at the length to width ratio, as we get farther closer to the sirloin, they get very narrow, and we call that a vein steak. And again, the retailers do not like that. And so beef on dairy, by adding that beef genetics, we're able to get a thicker, plumper steak towards the sirloin end. Okay, I got last two items I want to address. In the feedlot, 92-95% of all the cattle still receive an implant, a growth-promoting implant. It's an anabolic steroid-based implant. Many of you maybe heard, maybe some of you didn't hear, a couple years ago, FDA changed the guidelines. We used to re-implant cattle 3 times in the feedlot. Okay, we'd put 3 implants in. We put an initial one in, put an intermediate one in, put a final one in. Now it has to be on the label in order to re-implant cattle in different production phases. They came out with their Guidance 191 document that defined a calf ranch, defined suckling phase on the cow-calf, defined a dry lot, defined a grow yard, defined a feedlot. We're feeding these cattle. We'll bring in beef on dairy cattle to a feedlot weighing 350 pounds. They'll be on feed over a year. That means they can only receive 1 implant, or Zoetis now has re-implant label claims. But my point of this is, Tara talked about all the different colors. Right, here's some Charolais Holstein crosses. Here's Tara's favorite. These are Wagyu jerseys, Tara. And so I'm always asking my students, how are we going to implant some of these cattle? Well, these don't get implanted because they go into an all-natural program. But I've always, those of you that know me, most of my career I've worked with implants and beta agonists on muscle growth. And I've always been intrigued. Several years ago, Dr. Fox and one of his grad students at Cornell published a paper in the early 90s where Holstein cattle responded differently to implants than native beef. Okay, there was an interaction. And we repeated this. Dr. Caitlin Wesley, another one of my PhD students, we saw the same thing with a single implant. This was a Revelor XS implant, the red bar, compared to a negative control. The first 70 days, Holsteins didn't respond at all to that implant. Part of it might have been a behavioral issue. Beef on dairy were intermediate compared to the all beef. I've always had this hypothesis for several years that one of the active ingredients in implant is called trenbolone acetate. It's a synthetic androgen. It gets blamed for all the behavioral issues in cattle. But I've always had the hypothesis dairy cattle are selected for milk production. There's a correlation between estrogen sensitivity and milk production, right? Reproduction, we've been talking about that. So I've always had this theory that maybe the dairy cattle have more estrogen receptors on their muscle tissue, and we're able to delineate androgen receptors from estrogen receptors from membrane-bound receptors that can bind estrogen. And the first thing we showed in Caitlin's work, and we followed this up with some studies, dairy and beef on dairy metabolize circulating trenbolone, the synthetic androgen that's in the implants. They must metabolize it different because this is a classic. If you look at the black bar, we see this little peak at 28 days. Revelor X has 2 payout periods. And then we see this classic peak after day 70, and we've done many implant studies to show this. But in the dairy-influenced animals, we kind of blunt that response until later. So there's something going on in their liver of maybe how they're metabolizing that. But more importantly, if you just kind of focus on these first columns, we looked at the number of estrogen receptors on muscle fibers. And lo and behold, once in my career, my hypothesis was right. Holstein animals had basically 60 to 70% higher levels of estrogen receptors compared to native beef, and the beef on dairy were right in the middle. One problem we have with implants, especially in dairy-influenced animals, is we get buller activities in the feedlot. We get unwanted behavioral differences. And I really think that the estrogen receptors may be causing this. I think we need to rethink what type of implants we use on dairy, and especially beef on dairy, to try to maximize performance and reduce some of these behavioral issues that we can see. All right, so the last thing I want to talk about, I think I'm still okay on time, 5 minutes. So leading up till right now, I've told you a lot of positive things about the beef on dairy. And in a matter of 5 or 6 years, we have a product from basically the end of the strip loin at the start of the sirloin. If you go up to the head, I would argue that part of the beef carcass, the most anterior 2/3 or 3/4 of the beef carcass, is as good as any native beef you'll find in the United States, okay? But there's one thing we need to fix. Here's some pictures of the hind quarter. And I was told I can't use a particular word, right? So I won't use that word. But here's the hind quarter, looking at the hind quarter of the animals. And if you just compare the Angus, Jersey, and the Holstein to the all beef up here, which one has more muscle? The all beef, right? I talked about the muscle to bone ratio. There's a lot of red meat yield potential in the hind quarter of a beef animal, right? We all know that. That's the first thing we look at when we try to determine muscling of a particular beef animal. So we see this variation yet in the hind quarter. And in fact, Luke, on his work, we measured the ratio of the round circumference to the actual length from the H-bone up to the hock. Kind of like I showed you the steaks, the ratio of the length to width. This is the circumference to the length. And even the beef on dairy, Angus Holstein, Angus Jersey, they had less total muscle in the round compared to any of the all beef counterparts, and the all Holsteins were the worst, right? So there's a lot of red meat there laying on the table yet. And so my whole point, remember the ribeye size. Our main indicator of muscling, of red meat yield today, is what we call the USDA yield grade equation. The only determinant of muscle in there is ribeye size. I just got done showing you ribeye was the same. Oh, these animals are heavy muscled. But we got to look at the hind quarter. This is from Dr. Forker's dissertation work at Texas Tech. These animals had essentially the same ribeye size. They did. You could argue they were half siblings. Okay? This one looks like a calf-fed Holstein. This one looks like an all beef. Same ribeye size. I just got done showing you all of Luke's data. Same ribeye size. We need to do a better job of predicting the amount of muscle in the round. More importantly, is there anything we can do from a nutrition or management standpoint to make this guy at a young age or in utero come out looking like his half-brother? We still have, this is variation, right? This is what packers say they claim they don't like variation. I argue they can't measure it, but they don't want this. We've got to make them more consistent. So I'm going to end with a little study we did with a large feed company that has a research facility, and we're able to go in and take muscle biopsies on light calves. We did the longissimus muscle, and we took it off the bicep femoris as a measure of the hind quarter muscle. And we get individual muscle fibers in a dish, and then over time, very important cells called satellite cells will fall off of these muscle fibers, and satellite cells are responsible for postnatal muscle growth. They contribute their DNA to the existing muscle fibers. I'll talk more about that on Wednesday. I'll give you an overview of postnatal muscle growth. But the whole premise of the study is this large feed company is very interested in plane of nutrition during the calf raising, during the hutch period, how that impacts lifetime productivity. So we had what we called a low plane nutrition and a high plane nutrition. And you can see we had a dramatic difference in days 0 to 56 average daily gain. Day 0 being the day they came into the hutch, day 56 was weaning when they took the last bottle away. So we basically added almost 6 to 7 tenths per day of average daily gain. Multiply that, we're talking 4 to 5 pounds, right? So a very significant amount. The main difference here wasn't so much on the energy side, but it was uniquenesses of the protein components, specific amino acids, for example, things that many of you in the industry, or many of you in the audience are in the allied industry. You can help us with this. There's opportunities here to try to advance muscle growth early in life by simple nutritional mechanisms, I think. So this was our model. We biopsied these animals that had this dramatic of a difference in average daily gain the first 56 days. These are the cells once they fall off the fiber, and we can stain them for different markers to show what's their potential to become a satellite cell to donate their DNA to the existing fibers. So the important thing is, we did day 14 biopsies and we did day 56. So let's just focus at the end. Remember, I showed you all this data. Even in real commercial settings, there is no difference in the longissimus muscle area between a light muscled beef on dairy and a heavy muscled, or a beef on dairy compared to a native beef. The difference is in the hind quarter. We saw the same thing. No difference in cell activity, the number of these are dual positive satellite cells that ultimately are going to donate their DNA. Where we saw the difference was between low plane of nutrition and high plane of nutrition in that hind quarter muscle. That's what we're trying to make beefier, right? We're trying to improve the amount of red meat in that hind quarter. I think this is preliminary data. Another grad student of mine, Jerica Hall, is just finishing up her dissertation. I think it's a great opportunity for all our friends in allied industry. Different amino acids, different micronutrients like minerals and vitamins that can help stimulate these cells. What's interesting about muscle biology is everything starts in our back, right? If you've had embryology, muscle starts in the dorsal region and everything migrates from there. Isn't it interesting now that we've selected for the same ribeye size in the back, but some of those cells were too lazy to migrate to the hind quarter? Okay, we need help, and I think there's a lot of potential with nutrients and other management factors if we can increase the size of the hind quarter of these beef on dairy, they will be as good, if not better, than native beef. Last slide I got. There's no variation in the dairy industry, right, Lance? All the variation's got to be coming from the sires we're using on these beef on dairy. I'm really close friends with Dr. John Robinson, who's a former faculty member at Fresno State and a calf nutritionist and a dairy nutritionist across the country. He sent me this picture on a breeding line. I think these are second parity cows. He had birth dates on these. Less than 45-day range in age of these cows standing ready to get serviced again for probably the third time maybe, or second time. Back to what Dr. Felix said. They're maybe genetically similar, but their phenotype's not similar. All right, so some of the variation we see, the picture I showed of the two steers next to each other in southwest Kansas, did some of that come from the cow? I think so. I argued with the genetics company, and the breeder said they wanted to try it. Can we have two straws thawed, A and B? And a cow like this gets one, but a cow like this gets another. And maybe that would help reduce some of the variation, for example. So just some food for thought. But I don't think we can neglect what's coming from the cow. And we had some discussions this morning. Can we tap into all the data that you guys collect genomically on these dairy cows, that we can make more strategic decisions about picking the right beef semen to enhance our beef on dairy population? So again, I appreciate the opportunity to be here. Again, I think we have, in 5 or 6 years, we have elevated the quality of beef on dairy to extreme, very positive type animals. feedlot and carcass performance is essentially similar in cattle raised differently than calf. But I didn't show you any of the calf data. But basically, if you got nothing else out of my talk, we can get the same ribeye size on these beef on dairy, but that's really meaningless when it comes from a total red meat yield perspective. And I think if we can increase the amount of red meat yield in the hind quarter of these beef on dairy, they will be as good, if not better, than native beef cattle. So I appreciate the time. I'd be happy to take any questions. Thank you, sir.
Questions for Dr. Johnson?
Yeah, one right over here. Sure.
Thank you for the time. I have a question about what kind of product that you want to aim for this project. It's because of in my home country Indonesia, people doesn't like the dual purpose of beef and Holstein because they are more like fatty, like subcutaneous meat in there, and also the beef is not really dry because people in there like wanna make product. What kind of comparison that you wanna make?
So can you repeat the first part of your statement again?
What kind of product that you aim for this research, and what kind of comparison that you want to make? It's because of at the end we need to advertise this product, right? Because I asked this one because back in my home country, people doesn't like the dual purpose meat because there is a lot of fat, like subcutaneous fat, and also the beef is not really.
Okay. So yeah, in many other countries, of course, the United States is noted for high quality beef production. And when I talk about the marbling, the fat within the muscle, many people that have not grown up in the United States are not used to that kind of flavor and juiciness, palatability trait. But with the marbling inside the muscle, the main fatty acid that causes that is oleic acid, and oleic acid is tremendously healthy for human health, very heart healthy. But you're exactly right. Subcutaneous fat, we're trimming retailers or purveyors or packers even, they're trimming most all the subcutaneous fat off. Now the one fat I did not talk about, and I'll mention this a little bit on Wednesday, the most abundant fat in a beef carcass is seam fat, the fat between muscles. And so one thing we have seen with beef on dairy is we seem to increase the amount of seam fat. So if you've ever had a ribeye, there's that kernel of fat that divides the spinalis muscle from the longissimus muscle. And a lot of people don't want to eat that big thing. That's plate waste, right? And so those are things we need to fix. But the intramuscular, the fat around the perimysium, the connective tissue of the muscle bundles, that's the most desirable adipose tissue in a beef carcass, and that's what determines our USDA quality grade, and it's very, very human health. It's very good for human health. Just like olive oil, it's oleic acid is monounsaturated, very good for our heart. So yep. Yeah.
Excellent talk, Brad. Something that I just got to think, I know you've done a lot of work with other type of additives like repartition, like beta agonists, and that got me thinking on the F1 with the marbling, the amount of marbling that you have, and the issues with the dressing percentage. To what extent, if you care to comment, and if you're going to talk about this on Wednesday, that's fine. I'll wait.
No, I'm not going to tell. I know where you're going. Keep going.
To what extent there is an opportunity with some of those things with this new type of agent?
Yeah. So I could talk, give a whole nother talk on beta adrenergic agonists, or orally active growth promotants. Very first one used in the cattle industry was ractopamine, called Optiflex by Elanco. It was first approved for pigs as Paline. Really the game changer one was in 2006. We got a product approved called Zilpaterol or Zilmax. And that's where we really learned about feeding cattle longer, okay? That went away from perceived animal welfare issues. Many people don't realize this, but today Elanco has a product that they got approved that reduces ammonia emissions. It's called Experior. The active ingredient is called Lobabagron. It's a beta-3 agonist and a beta-1, beta-2 antagonist, where Zilmax and ractopamine are beta-1, beta-2 agonists. Since the sale of Zoetis to Phibro, and MGA finally got implemented into Experior, we've estimated 85% of the cattle in the United States today are being fed Experior from 30 to 35 days roughly at the end of the feeding period. Almost a large percentage of the beef on dairy cattle are getting Experior. Because Experior is a beta-3 agonist, it will literally melt the marbling away. They started feeding at 56 days and quality grade tanked, so they've choked it back to 30 to 35 days. The benefit is, I've worked with a lot of large feedlots, one up in the Pacific Northwest where they feed exclusively beef on dairy, and we're feeding Experior about 36 days, and we're adding almost 1% dressing percent to those cattle, but we've kind of got unique in how we did it with genetics, and we've had very minimal effects at reducing marbling. And so there's some opportunities there to learn a lot more, to get more red meat yield. Because now, Experior is a little different. I think I can say this. We used to use the term Zilmax butt, okay, the butt, the hind quarter of the cattle. If you've ever were around a feedlot that was feeding Zilmax, it had a preferential effect on the hind quarter. It had to do with the amount of beta receptors. And so I wish we could bring that product back just to do an experiment on these beef on dairy, because I guarantee you, with a little bit of Zilpaterol and some of these lighter muscled hind quarters, I could make them look like an all beef. Experior has a little different pattern. It's more global in its effect. But we need to learn a lot more, Nicholas. That's a great question. But we have to be cognizant we don't reduce marbling by feeding that particular product. So.
Thank you.
All
Let's
right.
thank Dr. Johnson.